All right, people, we're going to solve some quadratics by factoring. So this video is going to be a step beyond factoring. So by now you should know how to factor out a GCF, split the middle term, difference of two squares, regular trinomials, basically any type of factoring. To solve, you just take it one step farther, and that's what we're going to do in this video. So let's give it a shot. I'll do the first one with you, and then after, if you feel like you're ready to go, you can try the next couple on your own. So this guy, first thing we can do is factor out a 4x because it has the greatest common factor, leaving us with an x minus 3 when we're done. That's equal to 0. And you can't factor that anymore, so you're done factoring. But to solve, all you do is set each term with an x equal to 0. And then you would solve. So x in this case is 0, and x in this case would be equal to 3. So for this, we have x is equal to 0 and 3, and you're done. So again, after you factor, all you need to do is set terms with x equal to 0 and solve. So if you feel like you understand what you're supposed to do from here, pause the video, give the next couple a try, click play when you're ready, and we'll see how you did. But for number 2, the first thing we would do is factor out a 3, leaving us with x squared minus 25. And we can see the inside over here is factorable by the difference of two squares. So we would have 3, x minus 5, and x plus 5 equals 0. So we would set each of those terms equal to 0, and we would end up with x is equal to a positive 5 and a negative 5. No, the 3 has nothing to do with it. It doesn't have an x. So we can't set 3 equals 0. That doesn't make sense. So only terms with an x get set equal to 0 when you are solving. Okay? In example number 3, first thing you should have done is subtract the 12 over to the other side. Whenever you're working with factoring, the first thing you're going to need to do is get it equal to 0. Okay? And from there, you have more factoring to do. So the first thing I would do here is look for a GCF of 2. So I would factor out a 2, leaving me with 7x squared plus x minus 6. And that's equal to 0. We're going to factor this one by splitting the middle term. So 7x squared times a negative 6 would give us a negative 42x squared. But what would multiply to a negative 42x squared but add up to a positive 1x? And that would be a 7x and a negative 6x. But just like every time we factor by splitting the middle term, we bring down the last term, group those two, bring down the first term, and group those two. So from there, all we're going to do is factor out our GCF. So 7x leaving us with x plus 1. Factor out our negative 6, leaving us with x plus 1. And then we put our leading coefficients together for 7x minus 6. And our insides, which are x plus 1. Again, we did have a leading coefficient or a GCF of 2. But now we would just have to set each of those equal to 0. So we would have x is equal to positive 6/7 and a negative 1. Okay? Number 4. There was an example similar to this in another video where we had to use a shortcut. But there's no way to do a shortcut here because our parentheses are different. So this one, we just have to start grinding away. So we would have to square x plus 4, which would give us x squared plus 8x plus 16, and that would equal 2x plus 12 minus x squared. And again, when factoring, you need to get everything equal to 0. So we would have a 2x squared. Subtract the 2, or that's after we add the x squared to the other side. Subtract your 2x, that would give you plus 6x, and subtract your 12, and that would give you a plus 4. Factor out your GCF of 2, leaving you with x squared plus 3x plus 2 equals 0. To factor that, what multiplies the 2 but adds the 3 would just give us an x plus 2 and an x plus 1. Don't forget about your GCF of 2, meaning x is equal to a negative 2 and a negative 1. Now way back up here, if you were confused how I went from this to this, do not forget x plus 4 quantity squared would be written as x plus 4 times x plus 4. You would have to FOIL it. Don't forget, that's old school stuff. Last two examples are pretty much the exact same topic. It's just solving. But this time the directions are different. We're writing an equation in intercept form and then stating the zeros. So intercept form is just another one of our forms that we work with. But it's another name for intercept form is factored form. So you still just factor here. So here's another example of splitting the middle term. We would have a negative 18x squared. So what would multiply to a negative 18 but add to a negative 7? We would need a negative 9x and a positive 2x. Bring down our last term, bring down our first term, and group them together. Factor out a GCF of 3x, leaving us with x minus 3. Factor out our 2, leaving us with x minus 3. Put the leading coefficients, or the GCFs, together, and we would have a 3x plus 2. Our insides are x minus 3. And, of course, don't forget the y equals in front. That is intercept form. So it's just factoring. We put a y equals in front, and now all of a sudden we have an intercept form equation. To state our zeros, or also known as our x-intercepts, it's just like solving. We set these equal to 0, and you would get x is equal to a negative 2/3 and a positive 3. But to state them correctly, our x-intercepts, also known as our zeros, would be negative 2/3 comma 0 and 3 comma 0. Okay? So again, same skill, different way of writing our answers. So why don't you try the last one really quick. As soon as you're ready, click play, and you'll see it. So for this one, we would just have y is equal to, you should have x plus 5 and x plus 5. We could also write that as x plus 5 quantity squared, which means x is equal to a negative 5, and we would just have negative 5 comma 0. Now, with all of the factoring that we've done today, you have ways of checking, and one of those ways is using a graphing calculator. If you took your graphing calculator and typed this original equation in there, you would have a graph that looked a little something like this. And all you would have to do is find these x-intercepts with the calculator, and you would get negative 2/3 and 3. If you graphed this one, you would have a graph that looked a little bit like this, where it only touches the x-axis once at negative 5 comma 0. So never hesitate to use your graphing calculator to check if it is allowed on any quiz or test. Okay, that's it for solving and intercept form. This is Longo, and I'm out. See you, bye.